Mathematics, Advanced Subsidiary Level, Paper 1, 2022. Before you start the question paper, you must always carefully go through the instructions so you can read all the points. All I want to highlight now is just the degree of accuracy. So if the degree of accuracy is not specified in the question, and if the answer is not exact, give the answers to 3 significant figures. Give answers of size of an angle to 1 decimal place as in radians to 3 significant figures. Okay. Unless different level of accuracy is specified in the question. So that is just very important. And then for pi, use the calculator value. Very important. They don't say 3,142. They just say use the calculator. So for that, I just wanted to highlight that. So let's just go on to the next page and let's start with question number 1. Okay. So question number 1. And I always love it if a question paper starts with a very simple question because it just makes the learners a little bit more at peace. Okay, and they can just start thinking. So if I look at this, so the equation of a curve, there's the equation of the curve. Express this in the form of this where a, b, and c are constants. So it's actually just that negative. Okay, it's that completing the square of an expression. And where will I find this in the textbook? Now remember, what I'm doing different this year, I'm not taking out of the textbook, showing you. I'm just referring to the textbook. But what I will do this year, I will take the exam report and I will go thoroughly through the exam report. So I'm doing a little bit different. So on page 23, example 24 will help you, definitely. So it's just taking out that negative. Now remember, if you divide by a negative, then you're going to get negative 5. Okay, so the signs will just change. So this positive, this negative, this negative. And now I'm going to find, I just want to first leave the bracket. Okay, now to find that middle term, I'm going to add, and I'm going to take that middle term, 3, you can make it negative, but it's going to just turn into a positive. So it's going to, let's just make it negative, and I square. And I go negative 3 over 2, and I square. Now, it's not a plus, because of the expression, I just want to go back until there. So if I add it on one side, I will subtract it on the other side. Okay. So basically, now I can, and then I do a bracket like this, and I take the square root, and I take that sign, and I take 3 over 2, and I take square. Okay. And then it's going to be negative 5. And now, if I simplify this, it's going to be negative, but then 3 times 3 is going to be 9 over 4. Okay, which I will simplify now. Okay, so this will be, it's going to be negative 2 and a quarter, which I will add now. So I'm just going to put that step in. And it's going to be negative 7 and a quarter. And I do it like that. And now I bring that negative, not inside, just in front. So it's negative, then it's x minus 3 over 2 square. And a negative times a negative is positive 7 and a quarter. And that's what they want. Okay. And then I go on. And now don't forget, they use the word henge. Or otherwise, write down. Okay, if they say otherwise, you can do it on another method also. But henge say, look up and find the answer. So write down the coordinate of the turning point of the curve. Now remember, you can get the turning point from this form. You are going to change this sign. So it's going to be positive 3 over 2. And you keep this sign the same. And there you find your xy coordinate. Okay. And that's the answer. And now what I'm going to do, I'm going to take you to the exam report. Now, let's just find the exam report. And I'm just going to, this one is a bit more brief. So, luckily it's not the difficult work, so I think it will be all right. So let's first go to the general. Learners who displayed good algebraic skills coped well with this paper. An alarming number of learners are not up to standard for paper 1's work, specifically the algebraic execution of the work. Okay, execution of the work. Learners must be informed that if the question requires to show, prove something, the conclusion must always be stated again. So you must repeat the top. And they should not start with the quoted answer. You must arrive at that answer. It's important that candidates understand how to approach the henge part of a question. Calculator, that means look up and use the previous answer. Calculators and arithmetic skills are not up to standard. Okay, so make sure you can use your calculator. General comments, if learners use the additional page, they should indicate it on the question or delete the wrong working. So don't leave it, then they're going to mark the first option. So scratch it if that's your wrong answer. The standard of work in this examination was good for the able candidates, but the weaker learners' work was not well executed. In general, the work was done neatly and clearly. The marks range from 0 to 74. The majority of learners showed their working. So you must show your working. Working can score marks even if a final answer is wrong. Although the formula are given, quite a number of candidates were careless in using them correctly. Teachers must ensure learners get used to the formula sheet before the examination. So if we can, we're going to search for formulas there. It seems that all candidates were able to finish in time. That's a good thing. The weaker learners just left open questions after question. Okay. Now, this was the first. Did you see? You can just write it in that express in the form where A, B, and C. Doesn't matter. You can just leave it in the form. Otherwise, you can end up and say A is -1. This was the value of B, and this was C. Okay, but they didn't say name, so that you could have just leave it in the form. And then 3/2 and 7 1/4. And that was question number 1. Question number 2. Solve the equation, and this is very, very ordinary, straightforward quadratic equation. Okay, so let's start and rewrite everything. So it's 3x² plus 5x plus 4, and I think we can already take that 6 over. So it's going to be 3x² plus 5x minus 2, and that is equal to 0. Now, always see if you can factorize first, and I think this one can. So let's just check. So if it's 3 and 1 and 2 and 1, no, let's make it around. I'm just going to check. Okay. So it's 3 and 1 and 1 and 2. So it's going to be 6 minus 1, which is going to be 5. Okay, so the signs will be different, and the biggest overcross will get a positive, and this will be a negative. So I will get 3x minus 1 and x plus 2, and that will be equal to 0. Okay, so I will have 3x minus 1 equals 0, or x plus 2 is equal to 0. So 3x equals 1 and x equals -2. Divide 3. So the value of x is a third, or the value of x will be -2. Just like that. Okay, let's start with number B. Now, number B, and this is very important, they use the word henge. Solve the equation. So look up at A. Let A help you. Now, if you compare, see it's almost looking the same. But it's good to see, I can compare the first terms, but I think it's better to compare the second terms. And the reason why is that, because then I can see, oh, the value of x is equal to y to a power of a half. Do you see? There, the first term, it's just double. So I'm going to start by saying y to the power of a half is equal 2x. Okay, now I'm going to substitute. Now there is two solutions, but I'm going to show you at the end that this one will not be a solution. But for now, I'm first going to test it. So I'm going to say y to a power of a half, and because they say henge, I look up and it's a third. So when I multiply then with 2 over 1, and I multiply with 2 over 1, so y is equal to 1 over 9. Okay, now if I look at this one, then I'm going to say y, and now it's that negative, but I'll show you now. So if I put negative 2, now if I multiply with 2 over 1, and I multiply with 2 over 1, I get 4, but I must test it. If you look on page 13, I explained it very nice in my AS-Level Mathematics textbook. If you look at example 13, because of the roots, because it's actually, don't forget that this is actually the square root of y is equal to x. And the square root, if I go from exponential to root, is equal to x, okay, to this. So because, and I'm going to write it here, so because root square root y is equal to x, check your solutions. Check solutions. So I'm going to have square root y is equal to x. I'm going to check both and see, and then I'll show you. So if I'm going to put this 1 over 9, which is my value of y, and I must check if it's equal to that x a third, and then it's 100%. Excellent. But if I check this one, and I'm going to put this solution 4, and I'm going to equal to the negative, then I get 2, which is not equal to negative 2. So no solution. And I can end by say, therefore, only solution y is equal to 1. If you leave both solutions, you're not going to get your full marks. Very, very important. Okay, let's go to the exam report. So if I go, I just want to get it here. So let's just see the report, what they say. Okay, this was question 1. So let's just go to question 2. Was answered extremely well, but in part B, candidates still did not follow the henge instruction. Henge means look up, use the answer. Candidates have to realize the relationship between x and y squared. Many did not realize that this is not valid. Okay, you saw it out of the test. So there was your 2 answers, but the only solution was 1 over 9. Okay, very important. Question number 3. Given that the coefficient of x3 in the expansion of, and then they give you 2, this plus this is negative 1040. Find the value of the constant a. Okay, this is the binomial theorem. That will be chapter 2 in my AS-Level Mathematics textbook. Now, the best will be, and I'm just going to write down the pages to you, but I think what I'm going to, let's rather do it like this. Page 84, you will find nicely all that formulas. But what I'm also going, and then for the example, you can look on page 86 plus page 87. But what I'm going to do is I'm going to go to the formula sheet, because the formula sheet is going to help you with the formulas. So let's just go and see if we can find it there on the formula sheet that is given to you at the back of the question paper. Okay, let's see. Okay, so I'm going to make it bigger that you can see it. Oh, there I see it. There I see it. Okay. Now, usually on the formula sheet, they will just give you the straightforward one. Now, the straightforward one will always be like this. So it's just going to be, say, it's a plus b. So it's a to the power of n plus n over 1. then A, n minus 1, B, because then now what happens with that A, it starts counting down. So then it's n minus 1, n minus 2, and this one starts adding up. So there is B0, then it's B1, then it's B2. So basically, with just this, sorry, the line is not very nice. Let's rather go for a straight line. This will help you to find that solution. Okay, so I'm going to go back. Let's just go back. So if you could not recall it, you can just quickly go to the question paper, to the formula sheet and recall it. Okay. Now, what I showed you there is, and this is actually on page 84, that if there's a 1, it actually makes it far more easier. Because if it's a 1, then the first term will just be 1. It's almost like an exceptional case, and I just want to show it to you in the textbook. You can work with that one. It will be excellent. But on page 84, I just want to get my pen correct. You will find the extra, it's almost like a one that's adjusted if the first term is 1, which will be very helpful in this case. So it's going to be 1 plus, and then it's going to be n over 1, and then x, then that second term, because the second term was 0, then it's 1, and then it's going to be n2, and then it's going to be x squared. Did you see that? But as I said, you could have go with how they came to that 1 is that, and I just really want to show you this because some of you still struggle with the binomial theorem. It was actually, say for example, it's always that n0, so say it was n0, and then it was the first term, which in this case was 1, do you see? And n, and anything to the power of 1 is 1, and then n0 is 1, and that's how they came to that general. And if I maybe just rather maybe write it like this, a plus b, then that first term will be a to the power of n. Doesn't matter. But I'm going to make use of this one. Why? Because in both cases, if you look, it starts with a 1, so it's a perfect example to use this specialized one. Okay, so again, you only have to go, where will x be free? Now, be careful. It's going to help you. This is term 1. This is term 2. This is term 3. So don't think it's term 3, because then it's still 2. It will first be equal at term 4. Did you see that? Now, you don't have to write everything out, work everything out, but you're actually just interested in term 4. So you can basically just work out term 4 of this first bracket and term 4 of the second bracket. Okay, and then add it and then work with that statements. Okay, so can I just say, so you can write everything out, and I'm just going to show you, but I don't want to do it like this. You can go say 1 plus, because it's now in that case 6, so it will be 6 over 1, and then remember, because of the first term, so it will be the second term, and then to the power 1. Are you with me? And then you continue. But as I said, you are not looking for that. So it's so unnecessary, but please just take note that it's the fourth term. That will be x to the power of 3. Okay, so basically, I can just go for that fourth term. And now can I, another thing show you? I just cleaned it there. In the fourth term, and I think I want to show you until the fourth term here. So it was then n3, and then it was x3. Did you see that? Okay, so it will be n3. So then I can go just back, and then it will be 6. Let's just put it in. It's now not n. You can say 6, 3, and then it's negative 3 x to the power of 3. Okay, and you do exactly the same for that one. So then it's going to be, but now be careful that your value is now going to be 4. So it's going to be 4, 3, Let's just quickly write it down. So it's going to be 4 free. And then it's going to be ax, and it's going to be to the power of 3. Okay, let's just first get that statement before we start. Okay, so I'm just want to tell you on your calculators. So remember that we are using this key NCR. So basically we press 6 and then we press NCR and then 3 equals. And then what do we get? We are going to get 20. Okay. And then it's going to be negative 3 to the power of 3. And that is going to be negative 27. And then it's going to be x to the power of 3 plus. Okay, let's do exactly the same with this one. 4, so we press 4, NCR, and then 3. And then what do we get? We get 4, and now don't forget, it's a to the power of 3, x to the power of 3. Okay, so that's the statement. So I will now show you. I'm first going to add these two terms because I'm looking for the terms with x to the like terms, x to the power of 3. So let's just go for the 20, multiply the 27, and that's going to be negative 540 x to the power of 3 plus 4a3, so x to the power of 3. So you can basically now take out the x to the power of 3 as a common factor. So it's negative 540 plus 4a3, and it's x to the power of 3. Do you see that? Now that is representing the coefficient. So basically, I'm saying, and I can just show you, I say that negative 540 plus 4a to the power of 3 equals negative 1040. Okay, so that is the statement I'm going to solve to get a. So I'm going to say 4a to the power of 3 equals negative 140 plus 540. So I'm just going to, okay, let's just press. So it's negative 140. I can already write down to you the answer. It's negative 500. I can see that. So it's 4a3 equals negative 500. And then I'm dividing by 4, and I divide by 4. So I get a to the power of 3 is negative 125. And now I'm taking the cube root of negative 125, the cube root. So I'm getting that the value of a is negative 5. Okay, and that's the way I'm going to do it. So this is the binomial theorem, and look at that examples. That will definitely help you. But let's go to the examination report. So I'm just going to bring it in again. So there's the report. Let's see if we find it here. Okay, just going to make bigger that you see better. Okay, so this was question number 3. Candidates struggle to apply the binomial expansion. Although the formula is provided, it's on the formula sheet. Learners wasted a lot of time calculating their terms instead of the term in x3 as required. Okay, I think even if you just use that formula, and I'm just quickly, no, I didn't write it beforehand, and I'm looking for it. If you just use this formula, it would have also helped you just by saying that t r plus 1, let's just go. So r plus 1, and then that a equals n over r. A, that's your first term, n minus r, and then b, that's your second term, and that's r. Okay, so you can just work with that formula. Okay, and then they say a lot of time calculating their terms instead, and that was in my textbook also on page 84, instead of the term in x3 as required. And then they just showed you just had to work out that two terms as we did, And then you get the value of A is equal to -5. As your final examination approaches, allow me to emphasize the invaluable resource that the y equals mx+c mathematics textbooks can be in your journey to review and master the fundamental concepts. If you do not have a copy, you can find these mathematics textbooks at the following bookshops. May these textbooks serve as your trusted companions as you prepare for your final examination, illuminating the path to mathematical success. To all dedicated mathematics teachers striving for outstanding mathematics examination results, consider incorporating the y equals mx+c mathematics textbooks used by leading schools into your classroom. These textbooks are part of the NEED catalogue and can be readily ordered within your ministry's textbook budget. Be proactive in ensuring your request reaches the procurement department of your region and empower your learners with the best educational resources available. Additionally, please be aware that schools have the option to place direct orders with us, and we offer discount on bulk orders. You can simply reach out to us via email at the following email address. Best of luck on your mathematics journey.